Again, welcome to the SIG-Embedded meeting, and excuse me for starting it late, and hopefully we did not lose so many people on the way. Yes, I would like to start with organizational stuff. So if nobody would volunteer to take notes today, or is somebody volunteering? Otherwise, I can take notes today. None? Okay. So then let's see. Trying the moderation and note taking, but this shouldn't be a problem. Okay, I would like to start, if there are no questions or requests, with a short recap of the last meeting, Europe and US time zone. Let me quickly open this. So you should see my screen with the notes now.
Yes.
Oh, there's a frame around, so okay. Yeah. So okay. I need my note taking here. Okay. So yeah, so last time there were a bigger discussion about the proposal to replace libc, VASI libc with Lime 1, and the implications it would have for VAMA and the VASI SDK, which we have down here. There's an issue discussion going on in the VAMA community, and also there's a specific concern about the extended const feature. And also in the VASI SDK, there are some things to be discussed. And it looks like another breaking change for the installed base. Do you have any questions, any remarks to this, or especially from our friends from Asia, who I think are pretty close to the VAMA, not in the TSC?
I was just before. I'm very anxious to hear from the people who work on WAMR, but isn't this a curious thing? We've discussed the lack of WASI libc maintainers in the Go SIG, but isn't it? I don't know this. I don't know a lot about Lime, but just switching to another code base because we don't have enough maintainers for the current code base or something. That's like now we have n+1 squared problems. I don't know. Anyway, I yield the floor.
So if I got it right, you said that there is already a lack of maintainers for VASI libc, and if we now have a second version with the Lime 1, and we need to redistribute the already too little maintainers to two repositories, it wouldn't be better? This is what you said, or?
Yes, I'm speculating without knowing exactly what I'm talking about regarding Lime, but yes, that summarizes it well.
Topic, or shall we look at the next topic already? nothing. Yeah. I mean, it seems not everything would be bad. So looking at our use cases, I think having mutable globals wouldn't be the worst thing to have. So if you really want to share data quickly, but yeah, let's see. Okay, if there is no input request for that, I would jump to the next point, or the next thing which has been discussed, is the roadmap for long-term support for VASI Preview 1, or for something which is compatible to VASI Preview 1. And I think here we are in the middle of defining it, discussing it, and I was looking if there would be some interest or some input also from the people who could not attend the last meeting due to time zone reasons, maybe.
I'm sorry I was not able to attend that meeting. I was at the IoT Solution World Congress in Barcelona,
Awesome.
where once again, many people have not heard of core internet technologies, let alone things like WebAssembly.
Mm-hmm.
So anything we would establish as an LTS will become effectively the de facto standard to the mid, late adopters, potentially. Anyway, that's word from the street.
Yeah. So yeah. I mean, I mean, this is somehow also the hen and egg or whatever led to this idea of a long time support package for Preview 1, while the WASM standard evolves to something which will not be a preview anymore. So it will be P2, 3, 4, and then finally version, whatever. But the let's say fact is that there are already a lot of devices out there running on P1 and relying on P1 to be there. And I think for them we need to have a long-term support for what they are doing, and then hopefully in the end we have a good migration strategy to go to whatever version is out there. So I do see, or me personally, but also others see the two main efforts for the long-term support. The first would be to set it up and define what is in, what is not in, which is listed here already, and the second one would also be to have an ear close to the development of the official standard or the standard going forwards to see how we can converge in the future somewhere. Because I think this should be the long-term goal, because the LTS can only be supported so long, I think, and whatever time we haven't agreed on, but I think it's somewhere between 5 and 10 years, maybe. I don't know what your requirement for an LTS would be to really set your strategy upon. Do you have any input on that? On the second, or any requirements, ideas? What would make what would be your comfortable zone? When ideal would be forever, but yeah, this won't happen.
Maybe we could take a round of the people in this meeting, just make up a number in years.
Yeah.
This is not a commitment, it's just a canvas of what people think. I'll go first. 7 years.
I would go for a 10-year vote, but yeah.
Ron, I'm taking notes. This is why I'm a little bit lacking. You said 10 years, Thomas?
Yeah. Just as a guess.
Yeah. I would have, yeah. I mean, from our company, it would be 100 years, but I would say 8. So my proposal would be 8 plus a migration to whatever standard is out there in the end. So that you can, at the end of the support phase, or hopefully before a couple of months before the end of support phase, there's a way out, or there's a way forward, which has a reasonable effort, let's say. So
Yeah,
not rewriting everything. Yeah.
If you have that, then you could, my guess is that the amount of years can decrease if you have a good migration path. So
Yeah.
if the hassle of when a breaking change occurs is quite low, then you could shrink this the amount of years, of course.
Yeah.
But if not, you need to have it longer.
Yeah, definitely. Any other?
I would also go for 8 to 10 years if there is no migration path. But if there is migration path, I think that number of years can be shrinked.
Thanks.
I'll just add one vote to either yours or Thomas' suggestion.
Yeah. So I think we are somehow in the same ballpark. So Ron is super optimistic with 7 years, but yeah, somewhere 7 to 10 years, which is
I'm a radical.
yeah.
What's funny
which is,
though is I think that if we threw these numbers at people not in the embedded world, they would look at us like, that long?
Yeah.
You know, they would not. They would look at us confused the same way as we look at them with somewhat concerned look when they say, "Yes, we're deprecating this in 3 years." And we're like, "Wait, what?"
Yeah. Well, you could easily argue then, how long do you want your house to stay?
Yeah.
And how often do you want to throw away all your embedded devices in your house, for example? How often do you do that?
Yeah. I mean, on the other hand, if we go 10 years back and look into the, let's say, cloud space, cloud development space, I need to look up what of the technologies which have been 10 years back are still used used today for productive systems.
HTML.
FTP maybe. FTP is what.
Yeah. Okay. Yeah. But
It's
I'm
a
more
short
looking
list.
I'm more looking at things like I mean, containerization has been around, but I'm not sure about Kubernetes and what the state of serverless has been 2015. Things change, and they change more rapidly in the cloud space as they do in the embedded space. But this is 1,000 factors being I mean, for the cloud space, a little bit easier because usually you keep control over your deployments as a developer or as a company providing a SaaS, because you're operating usually. Yeah. And for us with the systems, we lose control over our systems because we sell them to people and they put them somewhere, maybe connect, maybe not connect. So it's a little bit harder for us. So 10 years.
I think it's very easy to argue on that because the embedded devices usually interact with the real world.
Yeah.
So they have direct impact on physical context.
To
some extent, be it a traffic light or transportation system.
Yeah.
Computer tomograph, whatsoever, and all these things tend to stay for a couple of while, right? So this is
because
updating those things is something that you only do if you have to.
Yeah, or even like changing a device or exchanging a device is usually more effort than changing a line in a YAML file or something. So
Yeah.
It's, yeah, but I think we all know. So let's figure a number out. I feel, and from talking to the other guys, that we will be somewhere in the decade realm, maybe. And this needs a community. This needs funding. So these are the nitty gritty parts need to be figured out. Yeah. Yes.
Just speculating for a minute. I mean, organizations that deploy devices that they do not plan to update are not really a concern until the point where they have to replace the device because it's failed.
Yeah.
So it's a different use case than the organizations that wish to use WebAssembly in order to do more continuous updates of code, where they're looking at it from a kind of different perspective as far as compatibility. So I just wonder about who falls in what bucket and to what extent they're willing to accept.
And please.
I can give you or I could try to make it a little bit more clearer. Some people also tend to want to have a more continuous way of updating and maintaining their stuff, even if they are in this rugged world where we have different cyber physical systems in place. So you, be it in the automotive area, aerospace, or in the factories, even in the houses, if you want to update your kind of the way you do interact with the artificial intelligence to improve the energy consumption of your building, etc. All these kinds of things made it very clear that updatability, manageability, flexibility, adaptability becomes more and more important. And in that case, you do not want to have the hassle because of incompatibilities that arise because the compiler toolchain is not working anymore, for example. Or the shipped runtime is not able to load a newly compiled artifact with an updated compile toolchain. This is something that we must be aware of, that this kind of additional efforts that then come up are hard to be accepted.
Yeah. So So this is also what I see and emerging, and maybe it's there already. So let's say the usual thing of deploy and never touch again of embedded devices, I think, is a little bit fading away, and having update capabilities, and even with WebAssembly, where I don't need to do a full update, but I can have like tiny behavior adaptations by just exchanging a payload here and there. And I think it's the way forward. And we need to stabilize the runtime, that the things are guaranteed to run, and you have real-time guarantees, performance guarantees. We have the sandboxing in blazed radius, all the things we discussed already. So this needs to be there. This needs to be understood, and this needs to be accepted, I think. But also need, let's say, the application management around, so that people can easily basically update the payloads. But I think that's a little bit out of our scope, but these are the things to happen. And then eventually people will do updates. I mean, it's not consumer market for us usually, so it's a little bit a different thingy, but still, yeah.
But it's important to understand that why this LTS idea came up.
Yeah.
Yeah, thanks for those comments and clarifications. I do appreciate it. And that seems like a reasonable framing.
Yes. Okay. As we are over these points and discussing them, so why not move forward? So there has been this platform discussion. I mean, we have this other document which I think you're aware of. I could I cannot talk and write and look it up at the same time, where we specified, let's say, the target platforms, and I think this is still valid for me, where we said this would be like Cortex-M class and so on and so forth, and with all the limitations coming in. So I like the Stevens idea to have a tier 1, tier 2 platform here, or systems, which need some alignment.
Yeah, and I think the idea is pretty pretty good to go for, because it allows us to move forward.
Yeah.
We just need to align on, okay, which with which systems do we start, and are these systems the ones that we want to fully support?
Mm-hmm.
So
my question would be, the granularity of these things. So me personally, or not personally, professionally for my job, I would, for me, I would be sufficient to say, okay, tier 1 is Cortex-M, and maybe Cortex-M3 and bigger. So maybe we can have Cortex-M0s out. Is this the scope of a tier? So like really architecture? Or is it rather tier 1 would be STM and Nordic Cortex-M? So how narrow would we lay the things?
I thought it was a list of capabilities more than specific architectures. I know that we have architectures listed, but just I'm more interested in capabilities than which exact.
Mm-hmm.
Just because there's a lot of interesting RISC-V things that will pop up long after we've really written these things, or maybe already exist.
Yeah. And with capability, you mean things like memory management units and stuff like that, or?
Yeah, exactly.
Yeah. Which is even more abstract, let's say, as architecture. So so I don't know how you think about it. So the advantage for me, pragmatically, to define specific chips. Let's say we are going for STM32 and the U5 series, for example. The, let's say, testing effort is manageable because there are only so many U5 chips, and it can just test them, basically test them all. If you go for architecture, the field goes wider, so having a acceptable test coverage is already a lot harder to do because there's so many chips out, and there's like basically on a daily basis you get new chips in. If we do it capability based, it will be even more complicated. So this is the advantage, disadvantage from, let's say, a test coverage side. On the other hand, and this is the trade-off here, if we are too specific, things will date out quicker than we can follow them. So let's say we are binding ourselves to the STM32 U5 chip, and then maybe there's a U6 or whatever 2 years from now, it will not be covered. So we are not flexible for development on the hardware market. So what do we want, flexibility or testability? So I don't know where we would like to lay the focus on. What are your thoughts on that?
From my point of view, this is quite a tricky thing because we are so widespread and heterogeneous, as you already know.
Yeah, we don't have enough representatives of some of these other specific communities to speak for themselves. I can't really do that. I can only speak for myself. So, but it would be nice. Maybe we need to try to do more outreach. I probably should have mentioned this group to more people I met.
Yeah.
Particularly people who had come from Shenzhen, who maybe we're not in as much contact with in this group, but we should be.
Yeah. Yeah, definitely. Yeah, and I think this is yeah. I mean, the only thing we can do here in this round is basically drive the discussion forward, give some input, put something in the notes which people can disagree on. Yeah. Let's see. Yeah. So it's I mean, and this is the what you meant, the heterogeneity of the stakeholders here. So even if I think about last year getting the scope fixed, so let's say the hardware platforms, the platform document. Maybe if someone could quickly pull out the link, because otherwise you would need to watch me pull out the link. This took quite some time. So and I see that I really like the tier 1, tier 2 idea, but I think this will take again a lot of time to set the scope here, what it would be. Yeah.
Dominic, if you want to, you could just scroll down and go to the Google Doc document that Chris
Thanks.
all into it, and then we could directly put in some comments.
Sure.
Because there we also. So what did we have? We had to have the duration time, so we could.
Yeah, I have noted it here. Let me quickly.
Yeah, I cannot edit it yet, but try to.
Also me not.
Yeah, we have to ask for Chris for it. Otherwise, just do the note. So duration time, we had something between 7 to 10 years, depending on the migration path.
Yeah. Sorry, I missed the link to the document, so I did not request access yesterday. Sorry for that.
No worries. Me neither. The list of platforms, OSS architectures. Currently, I hear that in this round, we do not have enough stakeholders to get a better view on it.
Yeah.
I just want to narrow it a little bit down. Things we need to put in place for LTS.
Yeah.
Permissible.
Yeah, I mean, we would need a contribution guideline. I would say, please.
Yeah, I see a lot of points which are all valid. The question is, who is picking this up, driving this forward?
Well, particularly the runtime question. Unfortunately, the one person from Intel who popped in had to leave apparently, but any WAMR maintainers in this meeting? I don't think so.
Yeah, in this meeting not. Usually yes, there are some of them, Liang He or Xin Wang, for example, but today not. So it's
because I mean that's really the cornerstone upon which all of this. I mean we have nothing to test if we don't have a runtime upon which to test it on. So certainly, this is a question we're going to have to answer sooner rather than later. As far as will there be more than one runtime actually signed up for this, and then who is it that will be helping maintain that so that it actually happens?
Right.
I mean, looking at it from a different angle, so and having all the discussions now, I think we are nearing our first full year in the embedded special interest group. Do we consider anything besides WAMR in this group where we're talking to? Is there somebody using anything else than WAMR, to be honest?
Do we ask if we are actively using it, plan to use it, or?
So all the discussions we had here and with all the people I talked so far, but maybe I'm biased or I didn't talk to the right people, but I think it all revolves around VMware currently. There might be something coming up, there might be something in the making, but as of today.
Yeah. So from my point of view, it's pretty much VMware. But I think there are also approaches like from Wasm2C that might kick in. Everything has its trade-offs. Of course, VMware seems to be as the one that is used most in the embedded space. If you look at Midokura, at Xiaomi, right?
Yeah.
Maybe it's not the best runtime, but the best runtime with the best relationship between pros and cons for this specific domain.
Yeah. I mean, as much as I love openness and flexibility, but the LTS as of today, looking at one runtime is so much effort that that it will be a really hard task to fulfill and get it running and get people in and need enough man hours in. And if we, let's say, open the scope, it wouldn't make things easier, and it would also really slow us down. So again, would be speed. On the other side, if we are too narrow to one thing, then we could create a lock-in and yeah, maybe even for the idea of the, let's say, long-term convergence of whatever VAS mainline is doing plus LTS might be harder if we are too narrow in scope. So if we are too specific in a problem solution, maybe there's no way of going back. So I would be happy with VMware only, but there are some implications with it.
I like WAMR and all, but I'd be very unhappy if we were WAMR only. I'm very actively trying to use other WebAssembly runtimes on embedded for a whole bunch of reasons, of which I will not take up the time of this meeting.
Yeah.
I'm not anti-WAMR by any stretch of the imagination, but there are other runtimes, like WASMI, for example.
Right.
Things that are outside the Bytecode Alliance per se. There's my own attempts trying to compile WebAssembly runtimes written in Go using TinyGo to run bare metal. For those of us who are perhaps dubious about real-time operating systems, again, I'm not anti those. I'm just referring to people I've spoken to. So it'd be better for us to establish some kind of specification. And if WAMR happens to be the only runtime that fulfills it, at least we have one. Okay, cool.
Yeah.
You know, but if we've written the specification too specific to the way that WAMR does things, then we perhaps make it more difficult for other runtimes to emerge that I'm sure even the WAMR maintainers would like to see, just because there's so many communities they're trying to accommodate right now. You know, some fragmentation of purpose may be good as long as it doesn't fragment the specification that everyone's trying to go towards.
Yeah.
That's my 50 cents.
Yeah, definitely so. Sorry, Thomas.
I would bring in another view on it from a kind of a business perspective. It's good to have at least two runtime in scope because that provides helps us in not falling into holes or having blind spots, kind of, right? A vendor lock-in is a thing to consider.
Yeah.
And it could also be that if we have at least two runtimes, then it might be that there's a higher chance to have a bigger community to contribute it. And maybe you could also take two runtime approaches that have their advantages for different use cases. So Could be that it's really super tiny microcontrollers where WAMR might not be the very best choice. Could also be that you have the grayscale when it's embedded and when not. If you think about edge devices, for example, if you think about WASM-Edge, for example, right? Or when you have to do inference kind of things, right? So I think this whole span is of interest, also for the embedded domain. It's not only very hard microcontrollers; it could also be ARM controllers. Cortex A, for example, not only Cortex M.
Yeah, definitely.
And that's why I think that having at least 2 runtimes could be a good thing. But as said, as of now, I would say WAMR is the most prominent one.
Yeah.
I mean, the only one that has full-time paid maintainers who actually are working actively on the concerns we discuss in this meeting. I mean, there are others, but they're not fairly focused on this.
Yeah.
So, yeah, absolutely.
I mean, again, software is about stealing, or I mean, reuse. So we could reuse Stephen's idea and maybe even have a tier 1, tier 2 runtime and say, okay, this is like WAMR will get all the features first, and then afterwards, or WAMR or whatever we decide on. Sorry, I would not push in any direction here. So we have a tier 1 runtime, which will get the next feature or the next iteration first, and then we have a tier 2, which is again best effort, and we try to follow with it. Yeah. So maybe it's a good idea to have this for runtimes as well, not only for platforms. So.
Yes, please.
So if there's nothing more on the runtimes, I would have a remark on the CI thingy.
We have to have a runtime to be testing anything on, so we can reverse the order of those maybe.
Yeah. So also, but what I'm missing a little bit, and this is also sparked by an internal discussion we had about let's say erosion or degrade in the VASI, in the SDK and in the compilation. But what I'm missing here is really, I think, what we need to do before we set up a CI and tests, that we need really to have requirements, and especially our, let's say, quality attributes like performance, code size, compilation time, all these things which we need to test for. I mean, we could start monitoring and then derive some numbers from it, but
we could start with maybe just smoke tests that prove that the specific feature set is even being fulfilled.
Yeah, sure.
And then everything you're saying is the logical next step.
Yeah, definitely. But we somehow need to set targets for that, especially looking at we have a tight wish for performance, but it would be hard for a CI to test against as performant as possible. So we need a number, and we have a code size and compilation time target somewhere in our heads, but I think we need to find some numbers somewhere, which will be super complicated, but these are things I would really see very valuable in the CI, and especially things like, if I look at performance, usually performance does not get worse with a single commit. So there's a single commit where you pass the threshold, but there's like a row of commits leading to this problem, and really monitoring the trend and seeing early on, okay, there's a rise in computation time or compilation time, and maybe I need to roll back a couple of things or take action.
I would propose to rather not to take absolute numbers on this, but to take a baseline, as you said, and then measure about the trend that is happening. So I'm not sure if we come at any time to a point where we say this and that, milliseconds, microseconds, seconds, whatsoever, is enough, and that suits for everyone. But I think what we can see, or what we can state, is that a newly deployed version on, for example, the WASI SDK is not rising by 10% in size from the output binary of a given benchmark project, or is not the compiling time from one version to another one is not rising by 20% on a given benchmark.
Exactly. We need to write the benchmarking first, and only then can we establish targets. Or even if we wish to, maybe we just wish to publish the benchmarks. And
we could also make it quite easy. Just issue in Hello World with a WASI SDK 20 and issue it with a WASI SDK 25 with the very same switches and bells and whistles that you put into the command interface for the compilation step, and look how big it gets. And if it rises too drastically, then you could just reject it.
Exactly, because performance may not be the benchmark you're aiming for. It is size or some combination. I mean, excellent point here.
And that's why I'm saying not go for the absolute number. So if you say it's 5 kilobytes or 50 kilobytes, yes, we need it to some point, but I think the trend is a very important thing to observe here in the CI/CD pipelines.
Yeah.
Maybe we can establish a short list of some benchmarks we think would be interesting to measure, and then figure out who can take on some of the tasks necessary to write some code to actually measure them.
No.
Right.
So let me write it down. So my proposal would have been compilation time.
Could be footprint.
Binary size, or footprint.
Yeah. And also
those of us who use Rust or TinyGo, compilation time, sorry, we're not going to fare too well. Execution time, yes, but compilation, not so much.
Yeah, it depends on. But I agree. Usually compilation time should not be that hard, but let's see. Execution time is very important. And therefore, we need
file size clearly really critical.
Sorry?
File size, as already mentioned, is obviously very critical.
Sorry, I didn't understand the word. Sorry.
Binary size.
Binary size. Oh, sorry. Yes. Yeah. Thanks. Yes. Yeah. Yeah. So I had. So I'm. This is on another screen where I'm taking notes because I cannot edit here. Sorry. So it's a little bit harder to understand. So yeah. So I have now written down compilation time, binary size, and runtime performance.
Execution time of the compile.
Or execution time.
Therefore, you need to define a runtime that must execute it, obviously. Otherwise,
sure.
You cannot check.
Yeah.
Hopefully, we could trigger like a arms race of people writing cool runtimes for microcontrollers that were like, "Oh, awesome!" I mean, that'd be great.
Yeah. And then again, we might have we might have like interactions here again. So if I optimize for binary size, usually it might come with a performance penalty. Whereas if I compile for highest performance, output might be higher depending on your code actually. So it's I think we have like how's it called, a multi-item optimization, and we need to have ways and flags to optimize for one thing or the other. Yeah. So.
Yeah, but you cannot go through all the permutations, right?
This
is way too much. But you're right. Of course, things might differ if you have other switches that you compile to or compile for, right?
Yeah.
For sure. We just need to define a minimal set of parameters to be tested, and then at every time compare against the baseline.
Yeah. Yeah. So. Yeah. So this is yeah. I mean, I'm fully with it, and I'm with the baseline comparison. One thing about CI/CD is that from my understanding, it's pretty binary in its expression. So it either fails or passes. So like there's no CI for trend observation, maybe.
Yeah, but of course, but you could put in in the CI/CD pipeline. Of course, you could just put in a script where you just say, okay, it's now getting worse, and that's why the CI/CD pipeline fails. Then you have to.
Yeah, we actually do that as part of the TinyGo CI process. As we measure binary sizes, and if they change, then we actually trigger a failure based on the size change if it's outside of a certain permitted tolerance.
But then so
that's kind of out of the scope of. I think we just need to say, here are some benchmarks you should use, and then potentially, runtime maintainers will then implement CI/CD with some of those benchmarks, and then implementers can go and look and see, okay, this one does better on this, and that one does better on that, and our requirements fit one of those better or not, as the case may be. But that way, it's more of a technical / business decision about which path to take, not just Whammer is your only choice. No. You get Whammer, which I mean is a good choice unless you're the Whammer team and you're like, wait, they wanted what? Yeah.
So it's getting more and more complicated. I have written some things down to put it in the document and let it grow. And I would say most of the questions here are so it can be resolved, and then we I still see the for me, still the biggest problem would be the funding, because I'm not sure if like a handful of people in their hobby free time could really drive a long-term support. So we would really need people spending more than an hour a week on this problem.
Yeah, for sure. But this is about the memorandum of understanding kind of idea that has been brought up by different companies, and also to involve.
I don't know that we should maybe not discuss that right now, but it's a key point. I found the memorandum of understanding somewhat lacking in weight, only because new executive management just, well, we have a new understanding. Sorry, you're out. If there's a commercial provider, then that sounds really good, until of course they're like, we just got bought by another company, and now all options have their negatives. If we have a specification towards what that means, then maybe a commercial entity says, we're going to do a paid support version of a runtime, which you can sign up for if your company needs it. But I'm not sure how well a memorandum of understanding is really going to work. I just fall back to the example of SQL. If you remember SQL 95, it was really successful establishing a standard. Everybody then did their own optimizations. The next SQL standards were completely useless because the language itself had changed too much. So I think if we can look at that as an instructive example of maybe what not to do here, it could be useful.
I'm sorry, we are at the end of the time, and for me also the time slot I have free. Sorry for starting the meeting a little bit late again, and thanks for the vivid discussion. I think it was really cool, coming a huge step, maybe not huge step, a step forward. Let's determine the size later of the step. And thanks for your contribution. Thanks for being here, and see you all around. Bye-bye, guys.
Yeah, thanks for organizing. We appreciate it.
Bye. Always. Bye, guys. Bye-bye.